In this video series, we will see how to use the large language models or LLMs, uh, also called as foundation models, through AWS Sagemaker. Okay, so in the first couple of videos, we will use these foundation models as it is, and then we will fine tune these models for our custom problems. So we'll see a couple of different techniques. For example, domain adaptation. So we'll train the model on our custom data sets, and then instruction based fine tuning. So this is to help the model understand our instructions or the prompt. Okay, and then finally we'll also build this RAG or retrieval augmented generation uh, based on our private or custom documents. Okay, and then we'll also build an application using long chain. Okay. um, all right, so uh, the AWS SageMaker, it has made all the foundation models accessible to us in the form of jumpstart models. Okay, we will see how to access those jumpstart models and how to fine tune and how to access those fine tuned models, etc. So in this video, we will use these high level SageMaker SDK, which is super high level with just a couple of lines of code. We can access and deploy these models and then start using. In the next video, we will see, but this very high level method, we can only access the models as it is. We cannot do the fine tuning, or we cannot deploy the fine tuned models, right? So that's why we'll use another method where we have much more granularity, so that we can deploy our fine tuned models as well. All right. Now, there are three ways to access these models or run these models. So, in this video series, I'm going to run all the code from my local Jupyter notebook. Okay, so this way I don't have to pay anything to run this code. Of course, to run the models, we still need to pay, but to run this code, we don't have to pay anything. But the other two methods are, so go to your AWS console and then go to SageMaker. Uh, the more common method these days is Studio. So you just need to create a domain. If you haven't created, then open Studio. So from the Studio, you can access the notebooks. It's very intuitive, very simple. In case if you find any problem, do let me know in the comments. I'll help you. And the second method is directly accessing these notebooks. Okay, so here I have created two notebook instance. If I click here, or if I start an instance, for example, start, and then that will take me to notebook, which looks very similar to the notebooks here, right? But for these two methods, because we are running the code on an AWS instance, so we get charged for the base instance, and we also get charged for the endpoints. Okay, whereas running locally, we get charged only for the endpoints, not for this code. Okay, so try to run this code locally. All right. So because we are running locally, just upgrade or update your SageMaker SDK, and also we are going to use this IPython widget. This is not important. Okay, this is just to create a drop down menu with all the models available, so that we can pick a model. All right. Now, so here we are defining two variables, model ID and then the model version. So the model we are choosing is this Falcon model via Hugging Face. Now, Hugging Face, it's another, uh, let's call AI/ML company, which host all these generative AI models, right? It's a very resourceful one. Go to their webpage and check. They host all the data sets, the models, the spaces, demos, etc., etc. All right. Now, for the foundation models, this model version is not important, or there is no model version. Okay, for example, this is more of a generic syntax. If you are using, let's say, XGB, XGBoost, or any other classical machine learning models, There we might have different versions. But for the foundation models, we'll have only one version of it. So the model version is not being used anywhere. But because this is generic syntax, we always say it's star. Star means the latest version. Okay. All right. So we are just creating this drop down widget. So Falcon, they have four models. Okay. So one is the 7 billion parameter, the other one is 40 billion parameter. Those are the two base models. And for the same two models, we have this instruct fine tuned models. So these are the models which are fine tuned based on some instruction data sets. In the next couple of videos, we will see what that instruct fine tuning is. Okay. If we want to fine tune a model, we always choose the base models, not the instruct based one. Okay, so keep that in mind. All right. Then we are creating this drop down. We are simply supplying the list and a default value. Okay, so here we are supplying all the options and then the default value, and this description it shows up here, and then this is just the style and layout type of thing. Okay, and then here we are creating the our initializing the widget. Okay, so it will show you a widget like this. So we have four models, right? So from these four models, we are choosing the instruct and the 7 billion parameter one, right? If we choose the 40 billion parameter one, we probably need we actually need a bigger instance to deploy the model that require more RAM, maybe GPUs, etc. But this is for demo purpose, so we always go with the lowest number of parameters model, which requires smaller instance. All right. So until this point, all we did is simply choose a foundation model. In this case, this Falcon model, which is actually developed by this company called Technology Innovation Institute. So they build state-of-the-art large language models. All right. Okay. And then here we have the Jumpstart model class, or we are importing this module from SageMaker. Now, I already have my IAM credentials, my role IAM credentials in my environmental variables. Now, because I'm running the code or the SageMaker SDK from local, I need to explicitly supply the SageMaker role ARN, which is also in my environmental variables. But if you are running this code on either SageMaker notebooks or SageMaker Studio, you don't need to explicitly supply this role ARN. Okay, so that's the difference, main difference between running the code on SageMaker resources versus our local notebooks. Okay, all right. So as I mentioned, I am already supplying my IAM credentials and also the role ARN because I'm running locally. And then we call this Jumpstart model. We need to provide the model ID. As I mentioned, we are not using the model version anywhere. If it is some XGBoost or classical machine learning model where we have versions, we would have supplied the model version as well. Okay, so in this case, we are supplying only the model ID and then the instance. All right, and also the role ARN. So this way we access the model. Now, to deploy the model as an endpoint, all we need to do is just call the deploy function using the model. Okay, that's all it is. So as you can see from here, it took me about, I guess anyone, about 9 minutes to deploy the model. Okay. Okay, I'll quickly show you when we run this code, what actually happens. So it does three things. So the first one, if you go to inference here, under models, so it first create this model, right? So SageMaker, it has these model artifacts corresponding to this model in one of their S3 buckets. What it does is it takes the model artifacts and create the model. So for example, if you from models, you click on this model, and the two most important pieces of information here is uh, this model data location, this star zz file, which contain the model weights. Okay, so those I think 7 billion parameters, 7 billion parameters, those weights. So those weights are within this zip file. And then this is the container, okay, which has the PyTorch or TensorFlow. So in this case, it is PyTorch libraries installed, and it also know how to process this file, the model architecture, their weights, and when we ask a question or when we invoke the endpoint, it already has the endpoint entry point script, so that it can give us the answer. Okay, all right. So this is the two most important things about a model. One, the artifacts, and two, where are the container which can understand the model artifacts. All right, and then some default parameters like this timeout. So this is in seconds, it's 1 hour. All right, now this is interesting. The SageMaker, it is suggesting the likely instances where this model can run. Okay, so this is the instance we have deployed the model on. I think we deployed it on 2x large. It cost us some $0.96 per hour, but it is suggesting this model can be deployed on this instance as well, which is much cheaper. But it's not always true that these suggestions are correct. Okay, it is only a informed sort of guess. Okay, for example, this 4 GB memory might not be enough to actually deploy this model. All right, okay, so that's the first thing. It has created this model, right? And then it will create this endpoint configuration. Okay, so endpoint configuration, this is the endpoint configuration. Now again, two pieces of information is the most important one, which is this model, and then where we want to deploy the model. Okay, so the SageMaker can access the model from this models, which is this one, and it deploy the model on this instance. And finally, it will create an endpoint. Now I have accidentally deleted the endpoint, which is why you don't see the endpoint here. But in one of the next videos, I'll make sure I don't delete it, and I'll show you the endpoint. But before deleting, we would have seen an endpoint here. All right. So that's what happened with this single call. Okay. So with this single call, three things happen. Using the model artifacts, SageMaker has created the model, and then it created this endpoint configuration, and finally it created the endpoint. Okay. All right. So, okay, that's it. And then now that we have the model in the form of this predictor, we can invoke the endpoint using the predictor. Okay, so we'll see a couple of examples how to use this model. Now, so here we have a prompt which simply says, tell me about SageMaker. Now, so the payload, it's a dictionary. The inputs is what our prompt, and then we can supply some configurational parameters. Now I'll explain these parameters in a minute, but this is how we invoke the endpoint. So with the predictor, we call predict, and we simply supply the payload, which contain two pieces of information. One is the prompt, and then any additional configuration parameter. Now this is not necessary. This is optional. We can simply supply only the prompt. So we get a response. The response always a dictionary containing metadata, when we called, what we called, etc. Lots of information, but our answer is within this list of lists, right, at this location. So this is the answer it came up with. Now, each model has a number of the parameters, but the four most important ones are these. The first one is this max new tokens. This is the number of tokens in the answer. Okay, so roughly each word corresponds to 1.5 tokens. For example, let's say 100 words corresponds to about 150 tokens. That's because the longer words, they can be split into 2 or 3 tokens. The shorter words, they typically one token per word. Now, why it is important is for two reasons. In this case, because it is endpoint, no matter how long this endpoint runs, as long as it is live, we are not going to charge the extra. But for example, let's say we are using OpenAI models, right, via their online endpoints. So in such a case, what we get charged is directly proportional to the number of tokens output, right? That's one reason. And the second reason is, if we don't specify this, the model try to generate the maximum number of tokens, which can be 5,000, 10,000, etc. We might run into these timeout error issues. Okay, so for those two reasons, it's always important we set the maximum new tokens. Now, if it is a question answer type of application we are building, where the answer might be just a few sentences or maybe a couple of words, etc., then we probably okay with maybe 100 tokens, etc. Whereas if you are working on, let's say, some story writing or maybe writing some book or something like that, then we might go for higher number of tokens. Okay, so that's the first and the most important parameter. And the second most important parameter is the token, which will take value between 0 to 1. Now, the way these large language models generate the text is, they take, so for example, let's say this is what we already have. The garden was full of beautiful. And the LLM, it generate the possible tokens or words for the next one. For example, in this case, it has generated, let's say, bunch of words: flowers, trees, herbs, bugs, and each word, it comes with a probability. Okay, here they are sorted in the descending order. Now, if we choose a very low temperature or low temperature, the words from the left side are the most likely words get sampled. Okay, if we choose a very high temperature, the words with low probability get sampled, meaning one of the words, for example, let's say we choose a low temperature, right? Now the answer we might get, it might be flowers or it might be trees. For example, the garden was full of beautiful flowers, or maybe the garden was full of beautiful trees. Okay, now, why temperature is important? Uh, it 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 based on what application we are building. For example, if we are building a question answering system, we want the right answer, right? So in such a scenario, we will go with a low temperature. So low temperature means always the token with the highest probability. Okay, so if we choose low temperature, and no matter how many times we call this endpoint or the model, we will get the flowers as the answer, because it has a much higher probability compared to next token, which is trees. Okay, so the answers will be repetitive, and depending on again our objective can be uninteresting, right? We will be getting the same answer. For creative writing like novel or exploring the ideas, etc., we might choose moderate to high temperature, so that we get different answers, so that we can build ideas. Okay, so that's the second most important parameter after max tokens, the temperature. And then two other important parameters, even it's very unlikely we set those parameters. One is this top k. So top k means, for example, let's say we set it to 2 or 3. If we set it to 2, which means select one of the words from the top k. Okay, if we set it to 2, either these flowers or these trees get selected. If we set it to 3, flowers, trees, or herbs, because these are the 3 top words. Okay, now there is one issue with the top k. Here in this case, the probability looks okay. It's distributed across these 3 words. But let's say the probability distribution is very skewed. Let's say the flowers has 0.95 and let's say trees has only 0.4 and this one has 0.01. So in such a case, what's happening is, depending on how skewed the probability distribution is, sometimes we might get these flowers, or maybe for a different application, we might get answer from the second or third token as well, right? So it's a bit uncertain choosing the k value, especially when the probability distribution is skewed. So to overcome the challenge, we have an additional parameter called this top p, which is more dynamic. So instead of choosing the number of tokens, here what we are choosing is the cumulative probability. For example, let's say we have chosen it to 0.75. So what it does is, it goes from the left to right, it select as few words as possible, so that the cumulative probability is equal to, or not equal, is closer to our threshold value. Okay, so this is the it sample from the smallest possible set of words. So in order to sample from smallest possible, obviously it need to go from left to right, meaning the highest probability to the lowest probability side, right? And with the cumulative probability slight greater than our top probability. Okay, so those are the four most important parameters. In most applications, we don't even choose top P and top K. We definitely choose the number of max tokens, and we will choose the temperature also depending on our use case. All right, cool. That looks good. So here also it is showing, okay, because we have this time, it's showing how much time it took. So it took about 2 seconds wall time. All right. Now, so as I mentioned, these Falcon models, these are the state of the art models developed by this Technology Innovation Institute. Now we are using this 7 billion parameter model. They also have this 40 billion parameter model. Now these are trained on roughly 1 to 1.5 million tokens. Okay, 1 to 1.5 million tokens. So if you are interested, you can go through more details, like what data set is used to train the models. Was there any some instruction based fine tuning? What data set used for instructions, etc. Okay. All right. Now here let's just test the model a couple of different ways. Okay, we'll try to design the prompts for different use cases. All right, so here we are writing a simple function, query endpoint. It's just the same as before. We are calling the predictor function with a payload, and then we are printing the input as well as the output, but nicely. Okay, so this is what it is. So this part, it's just this input and output in bold. So here is our prompt. We are saying write a program to compute the factorial in Python. Okay, max tokens 200. As I mentioned, most likely parameter we use is max token. All right, so it has generated this code. Let's actually test if it working correctly. So yeah, that looks good. 5 factorial is 120. That's 5 times 4 times 3 times 2. That looking good. 3 factorial should be 6. Cool. 4 factorial should be 6 times 4, 24. Right, nice. So it has generated this piece of code and it is working as expected. And here is another one. So building a website can be done in a building a website can be done in some simple steps. So here we are asking the maximum number of tokens should not be more than 110. Okay. All right. So now this one, I don't remember on top of my head. It's again how repetitive the tokens can be. Okay. For example, sometimes when we ask, okay, give me a list of 100 ideas, it might happen that some of these ideas are exactly the same, right? So the tokens used can be exactly the same. So if we want to avoid the repetition, we can set a limit on the tokens as well. Okay, how the tokens are sampled, if they are sampled before, can they reappear in the text, etc. All right, so this is our input. And here we have an output. So it says, okay, choose a domain name, register the domain name. Okay, that looks good. Choose a web host or provider, choose a website design, so on and so forth, right? So this is looking great. Now we are looking at a few shot learning, right? So in few shot learning, we make we provide some examples of our question or our input as well as the expected output, so that the model uh, answer as per the style we provided and as per our expectation. Okay, so here we are saying translate English to French. Now we have provided three examples, right? Okay, see author. Yeah, I don't know French. So here we have provided three examples. And then we are asking, hey, what is a cheese called in French, right? All right. So it came up with this answer, fromage. Okay. Yeah, probably that's right. I don't know. Another a few shot learning example. Mostly a few shot examples shine when we want to do some sort of classification. Okay, so here we are doing some sentiment analysis or classification. So we have an input prompt which input which says I hate it when my phone battery dies. The sentiment is negative, and here my day has been this emoji. It's positive, and then we have a neutral one which is this link. This is the link to the article. Obviously this does not convey any positive or negative emotion, so it's neutral, right? And then finally we want the sentiment for this one. The new music video was incredible. It says the sentiment is positive. Okay, that is looking great. All right. And finally, not finally, we are going to see a couple of more examples and another LLM model as well. So here we are saying, could you remind me when the C program was invented, etc. Now, this is more of a factual answer, right? So now, all the questions we have, I mean, for example, this question, we can think that somehow these LLMs, they have this natural language understanding capability. So when we ask, it knows the answer can be either positive, negative, or neutral. Because it can understand the language, it answered it positive. That seems reasonable. But how did this model answer this factual one, right? So here we are asking, hey, tell me the year when the C programming is invented, and we are also asking who invented it, right? So the 7 billion, which we saw here, the number of parameters. Now, all that factual information is encoded in the form of weights within these parameters. Okay, so that's why these large language models, they are able to uh, uh, provide these factual answers as well. So the model is saying it C language is invented in 1972 by Dennis Ritchie at Bell Labs, which is correct answer. All right, and then another example. What is the recipe for a delicious lemon cheesecake? This time it's quite nice. So it is saying, hey, these are the ingredients you need and the quantity we need, and then the instructions step by step, right? This is quite great because we asked a simple question. We did not say provide me the ingredients, their amount, and the step by step instructions, right? So even with this very generic prompt, because these are state of the art models, I mean, those are learning and improving day by day. It understand what our intent is, and it provide this complete solution. Okay. All right. Here is another example, text summary. So we have a very large text about LLM models, and then in the prompt, so here we said summarize the article above. All right, and we want to summarize this within just 200 tokens. Okay, so we are printing our input, and then this is the output, which is the summary of our input, and this will have at max 200 tokens. Okay. All right. We already discussed these parameters. As I mentioned before, always keep in mind to supply the maximum number of tokens. Otherwise, you run into two problems. Your bill will be more, it will be expensive, and also you might run into this timeout errors. And finally, here is an interesting way of using these models. So let's say we are writing a book or novel where the number of max tokens is very, very large, right? So we are asking for 1000 tokens. To avoid the timeout errors, what we can do is we can set, we can call the models iteratively. So here we are setting max new tokens in single iteration, okay, is 100. So which means we are going to call the model 10 times, right? But there is a tricky thing. We want our answer to have continuity, right? For example, let's say when we call model first time, it has generated some, let's say, a small paragraph, and then when we call it, generate another paragraph. But we want the continuity between those two paragraphs, right? We'll see how to achieve that continuity or maintain that continuity. So to the prompt this time, we are supplying this additional parameter max new tokens. Okay, this is not max tokens but max new tokens. So the model understand, hey, I'm going to work iteratively. Okay, but that's not enough. The model also need to know what it generated previously. Okay, so the way we are going to achieve that is, so here we have a loop, and yeah, so we are doing it until we achieve the maximum number of tokens, the maximum number of tokens. Each time we have a limitation. Okay, so we want to generate 1000 tokens, with each time only 100 tokens. Now we call the model as was before. It has generated some text. Then what we are doing is we use the input we provided. We are taking the generated text, we combine it to make another variable, and this time we have updated the payload. Okay, so when we run the first time, the payload is simply what our prompt is. Okay, but this time the payload contains our input prompt plus what was generated previously. So if it is the first time, there won't be anything, right? If during second iteration, in addition to our prompt, we are supplying the model what we have generated during iteration 1. Okay, so this way the model will be able to maintain the continuity between different iterations. Okay, that's quite nice, right? um, all right, so yeah, so uh, when you, I mean, if you are going to use these models live, obviously you will keep the endpoint, but that's going to cost you money whether you use the endpoint or not. So that's why it is always a good idea to delete the endpoints. Now here we are deleting the model as well as the endpoint. Now we are going to get charged only for the endpoint, not for the model, because as far as I know, it will be maybe a couple of hundred MB will be sitting on S3. So I don't think we get charged for having the model here. So as I was showing here, we don't get charged for having all these models. Okay, so keep the model as it is, and delete only the endpoint. Now, if we delete the endpoint this way, it will delete the endpoint configuration as well. So remember I said when we deploy the model using this command, the SageMaker is doing three things on behalf of us. One, creating the model using the model artifacts, then creating the endpoint configuration, and then using the endpoint configuration to create the endpoint. Now, what I suggest is we don't get charged anything for endpoint configuration. So I always delete only the endpoints. I keep the endpoint configuration. The reason is, for example, let's say we want to deploy this model again. Now, we don't need to find out where the model artifacts are, which instance we used the last time, which might be the best instance we found out after a lot of research, etc. Right? So we don't want to lose all that information. So that's why I always keep this endpoint configuration. Then what we can simply do is we can just clone to create a new endpoint configuration if needed, if we want to call with a different name. But by simply clicking here, we can recreate the endpoint. We can recreate the endpoint without going through all the code, finding out model artifacts, etc., etc. Okay. Uh, all right, and quickly, I'll show you the Llama models, which are the latest kit in the foundation models. So these models are from Meta. They have open sourced the model, which are doing quite well, right? Now we have three versions of the model. The Meta text generation Llama, so 7 billion, 13 billion, and 17 billion. Uh, I tried to deploy this model, but ran into these errors because the SageMaker, it hasn't made these models available in all the locations yet. Currently, it is working only in US East region. I am in AP Southeast, so I cannot deploy this model. So I ran into this error, but it is not actually related to ZZip. It's just that the model is not available in the location where I am. Uh, just a couple of points. So as I mentioned before, all models, they more or less have the similar configuration parameters. So the max tokens, the temperature, top P, and it don't seem to have top K. Yep. So very similar configuration parameters, and then we have some limits on the tokens. So if we are going to use this Llama model, check out these limits on the tokens. And just one thing, this licensing thing, uh, it's a different license. So this company, which is this, sorry, where is, yeah, the Technology Innovation Institute, uh, it's one type of, or the complete open sourcing. So one can use these models even for commercialization, etc. Whereas the license agreement for these Llama models is slightly different. So they say this end user license agreement, we need to accept it. So this notebook, which I'll provide the link in below, both the notebooks are from SageMaker itself. Uh, uh, so when we are using the model, when we need to accept this end user license agreement. Okay, that's the main difference. Otherwise, how we deploy the model, how we access everything is exactly the same. So maybe in a few days, we'll have the model available in the other locations as well. Okay, that's all for this video. In the next few videos, we go in depth. We'll do the fine tuning. We'll see more NLP use cases. Okay. Thank you very much.